I'm excited.
Vocal warm-ups.
I'm excited to do episode X.
Episode X.
X.
Like Planet X.
Planet X. It's coming to kill us.
Dun dun dun.
Dun dun dun. Hi, Kovi.
Yeah, how's it going, Benjamin?
Top
of the morning.
Top of the evening. One day we'll get this sorted out. For those of you at home, one of us is on the other side of the planet. One of us.
The round side of the planet.
Mm-hmm. Man, that's a fun little intro. Talking about Planet X, the round planet. It's a good little intro to today's topic.
Yeah, it's almost as if that was intentional.
Today, hello everybody. Oh, go on. Do the.
I just wanted to.
Go on. You talk.
I did want to welcome all of the guys and gals and non-binary pals, folks listening from home, and in the air and on the land and at sea and under the sea and in outer space, whatever medium you are listening in and listening through. Welcome to our 10th episode of The Nerd and the Scientist, presented by Science, actually.
Oh, that's a nice one. I like how you put that. I was convinced Kovi was going to buy a plane ticket, fly over here, and just kill me right around episode 5. Thanks to budgetary constraints, he did not, and we're still recording.
These are the same budgetary constraints that led us to beg the 0G organizer on Twitter to give us a free 0G flight, because they normally cost how much?
Oh, God, I think it's a few $1,000s. It's not free. Wow. It's not cheap. Yeah. But to my credit, I did beg them for a good solid month.
Hey, at least you tried. That was good. That was good.
Yeah.
But yeah, today we are going to be talking about something that's even more fun than a 0G flight that goes up and down until you vomit. That's why they're called a vomit comet. But instead, we are talking about conspiracies.
Ooh, space conspiracies. Get your tinfoil hats ready, ladies and gentlemen, because we're doing a deep dive into the nope, not true of space.
I feel like that's a spoiler, but also it should be kind of obvious for our listeners that, yeah, most conspiracies, almost all conspiracies, tend to not be true. I hope that isn't ruining everything.
It's just, it's show your work. Show your work. You can have any theory you want. That's great. That's great. Show your work. Where's the math? If you can't do it,
Pixar didn't happen.
Exactly, Pixar didn't happen. For example,
have you seen that infographic? Oh, sorry.
I've seen many infographics.
You've made many infographics as well.
Yeah.
There's this great one that's floating around the internet of the timeline of reported miracles, or the number of reported miracles as a function of time through history. And there's, all these miracles purportedly happening in, the pre-modern era. And then the function just kind of drops to 0 with the invention of the photograph, but then it climbs back up again with the invention of Photoshop.
Yep. I've seen that. It's brilliant.
But yes, what do you have for us today? Where are we starting on this wonderful journey? There are a great
many conspiracy theories about everything, and about science and about space in particular, some of which I'm sure many of you have heard, but we're going to start us off with some that you might not have heard of before that don't get as much airplay. None of them really should. We're going to start you off with something called the world ice theory, or the world ice doctrine, otherwise known as the Welteislehre. The Welteislehre was a concept proposed by Hans Horbiger, an Austrian engineer and inventor. And he first envisioned this theory back in 1894 and published a book in 1912. And he promoted it for years in newspapers and other periodicals, gave lectures. He spoke at many astronomical associations of the time, promoting his theory that the world, and not just the world, but the entire universe as a whole, first started as a singular block of ice. There was a massive emergence of ice, and everything was connected to the ether, which was ice, and it broke into smaller pieces, which were the galaxies, which broke into smaller pieces, which were stars, which were broken into smaller pieces, which were planets, and everything thawed to become what it is today. Your response, Kavi.
I have questions.
And they cannot be answered because this is a conspiracy theory.
But like, it's not even coherent. Oh my god. How? What?
Yes.
So the basic assumption here, are
Yes.
we talking about water ice?
I just read that it was ice. I was doing way more laughing than I was doing sincere note taking when I was researching, and when I came across the world ice theory, otherwise known as the Welteislehre, which is
I love
really
it when you
fun
say
to
that.
say.
Say it again.
Everybody, say it with me. Welteislehre.
Welteislehre.
The Welteislehre. There's no logic to it because it presumes that ice existed. And we're talking an insane amount. There's no beginning, there's just ice. So I don't understand how he proposed it, how he came to think it up. He worked with another astronomer of some renown in Austria during his stay, and they spoke of it together. It was kind of implied that excuse me, that Hans Horbiger kind of convinced this poor astronomer that this was the origin of all things, but nope, that was a very popular theory that has been severely and thoroughly debunked. But that's how we're starting us off. Conspiracy theories. Words are slayer.
I feel like there
Marcus
should be
Fabius
some
had
sort of
exploded.
minimum threshold to call something a theory.
Right.
Like, I could equally say the whole universe is actually just jam. It's just jam, right? It just all started in jam, and
What kind?
then it broke up
Raspberry or
into
strawberry?
obviously rausberry.
Are you
So
kidding
what kind
me?
of question is that?
Strawberry.
Well, the strawberry is like the dark matter, I guess, in this universe. There's like no, but seriously, there's not even an attempt at a theory there. Everything was ice. What about the planets? It came from the ice. Oh, okay. Cool. So, like, this whole idea of, that we have proven time and time again that, because of the way that light is limited to traveling at a finite speed, as we look further out into space, we are looking further back in time because the light takes, a measurable amount of time to reach us, right? So according to this theory, we'd reach a certain point when we're looking out deeper into space and further back into the history of the universe, where we'd just be like looking into the inside of a freezer. Is that what?
We'd just be staring back into a giant wall of ice.
Oh, that's nonsense. I love it. I love it.
That was some really good debunking right there. I love it. I love it. I love it.
It wasn't even bunked enough to deserve a debunking. It's just bunk. That's all it is.
It's just
Sorry,
been
go
bonked. It's just bunk.
on.
All right. Here's the next one, and this one was a bit more recent of a kind of conspiracy theory, and it actually had some
Hmm.
traction. By Immanuel Velikovsky in
Okay.
1950, he wrote a book that proposed
Oh, I can tell there's going to be scientifically sound already.
oh, it is so sound. According to this book, Kavi, did you know that Venus did not exist about 500-600 years ago? And that a large body smacked into Jupiter on one end, and on the other side of Jupiter spat out this massive, massive comet that ping ponged its way around the solar system and eventually found its way into a stable orbit and became what we call today Venus. And his proof for this was that it's true because it lines up with many stories in the Bible, as Venus was ricocheting all around the solar system. It swung by Earth during the time when, during one fable in the Bible, the sun stood still. It swung by again when the Red Sea was parted. It swung by again when this miracle or that flood or whatever happened, until eventually, when all the biblical stories came to an end, it was when Venus found its way into a nice, safe, stable orbit. Your thoughts?
All I'm thinking right now.
I am watching Kavi's head just literally pulsate. This is fantastic.
Oh, you can see that vein? You can see that vein in my forehead. Okay.
Keep
Like
going.
like even
Keep going.
even putting aside the orbital dynamics, um, that would just no. Putting that aside, there is so much historical evidence for Venus that dates back to like the ancient Egyptians, right? The ancient Egyptians would refer to, okay, so Ra was the ancient Egyptian sun god. Yep. And so
Yes.
pharaohs were, considered divine monarchs. I'm not an expert on Egyptology, so if anybody listening, um, wants to quibble with me, you're welcome to quibble. But I think what I'm saying is roughly accurate as far as Egyptology goes. Um, so the pharaohs were considered to be divine monarchs as related to the sun. They did not represent the sun, and so you would have Ramses, for example, the pharaoh, who was Ra Mses, which means son of Ra. Right? You're the child of the sun god, and they would refer to him as the morning and the evening star. And that, as far as I know, and I might be wrong, but I'm pretty sure that refers to Venus. Why is Venus called the morning and the evening star? Because Venus's orbit is closer into the sun than the Earth is. Therefore, whenever we see Venus from Earth, we see it trailing the sun, right? So that first bright star that you will see after sunset will normally be, depending on the time of year and the orbit, will be Venus. And the last star that you will see before sunrise is generally also going to be Venus. Therefore, Venus is the morning and the evening star. So if the ancient Egyptians knew this, I mean, by my calculations, ancient Egypt was a lot longer ago than 500 years.
Yes.
And it's not just them, like it's the ancient Greeks, right? And just like all of the cultures. Just oh god.
So no.
Yeah, that's a big old, it's a big old no.
That's a big old no.
Yeah, Yeah, like you have like ancient Persian astronomers and ancient Greek astronomers and ancient Babylonian astronomers all talking about Venus. Um, so yeah, I would mark that up to a not great theory.
No, especially one from the 1900s.
Oh god. Hey, at least it's better than Ice Universe.
Welteislehre.
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 It's a new catchphrase for the show. Welteislehre.
That's going to be on
Oh
another
man.
t-shirt. I have no idea how that's going on a t-shirt.
Ah, I think we are already at our first ad break.
Let's do it.
Oh. Benjamin, is there a particular product or fun thing you would like to tell us about this week?
Copy. Ladies and gentlemen, step into the realm of absolute protection with Uncle Whammy's tinfoil hats. Are you tired of wondering if extraterrestrial beings are scanning your thoughts? Fear not, for our hats are guaranteed to hide you from aliens and prevent brain transmogrification. Keep your mind safe and sound. Crafted with top secret space age technology, these hats are not just an accessory, they're a shield against cosmic invaders. Order now and receive a free alien repelling keychain and our exclusive guide on how to stay stylish while staying safe. Don't let the unknown invade your thoughts. Join the enlightened few under the shimmering shield of Uncle Whammy's tinfoil hats. Uncle Whammy, protecting you, buddy.
And what's whammy short for?
I don't know. I just wrote it up. Uncle Whammy.
The name's William, but my friends call me Whammy.
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 You know what? I think tinfoil hats, I mean, in theory, they're good, right? It's an important role. We need to keep the aliens and the mind readers out of our brains. But I don't think tinfoil actually works. I think it's just a conspiracy by Big Tin to convince us to buy more tinfoil.
Well, that's a question. Tinfoil and aluminum foil are the same thing, but which are they made of?
Oh.
Oh.
Ooh.
Oh.
Oh. Oh. Okay, so that's a freebie conspiracy that we managed to sneak in
Freebie.
there.
All right, here's a good one that I hope I can find an astrophysicist to answer this one. Should be simple-ish, but this is actually a popular, unfortunately uneducated conspiracy theory. The moon does not rotate. How not rotate? How do we know? Because we only see one side. Go.
Is this a conspiracy?
I don't know if it's a conspiracy. It's just
But
no. It's not really a conspiracy. It's kind of not. It's not conspiracy. It's conspiracy-ish. It's conspiracy adjacent.
I feel like you really don't need a lot of tools to be able to observe the rotation and orbit of the moon, right?
Right.
So there's always a different part of the moon that is illuminated, right? Because the moon is going to be orbiting around the Earth, and it will have a different relative position to the sun. So that the side of the moon that's facing the Earth, that's facing the sun, sorry, will be the part that's completely illuminated. So when we see a full moon, it means that the sun is behind us, but it's not like a straight line, because if it was a perfectly straight line, then we would have a lunar eclipse, right?
Yep.
So roughly speaking, the sun is behind us, the moon is in front of us, and that what we see, the full moon is that completely illuminated side of the moon. But then throughout the month, we see less and less of the moon as it both rotates and orbits, and so we see a little bit of a dark part of the moon, and we also see some of the illuminated part, which again depends on its rotation and orbit. I I feel like this could be the sort of thing that you could just measure those things yourself, and you could track that over a month, and you would see the evidence to debunk the thing.
There you go.
Is there something else I'm missing here that's maybe a bit more
No,
complicated or subtle?
that's just it.
That's just it, right?
Next one. Let's move on to the next one.
Next, batter up.
Pulsars
Pulsars.
are artificial beacons put in place by aliens.
Oh,
What's
is that a question? No,
What's
they're
a
not.
pulsar, Kovi? Covs. Hey, Covs. What's a pulsar?
Benny boy, Benny, meet me Ben, Benny McBenny Ben. Pulsars, Benny McBenny Ben. You know, I feel like, I don't know if this is just a uniquely Australian thing or it's also with America. Whenever there's like a naming competition for some government,
Bodie McBoatface.
Yeah, so it's Bodie McBoatface. There was a similar thing here for an Australian space mission recently that was almost Spacey McSpaceship, but that wasn't allowed. Rockety McRocketface, something like that. But yes, pulsars. Pulsars are really, really, really interesting because, well, firstly, when they were originally discovered, the original theory, people thought they were aliens because there was no good explanation, right? And that's how kind of like a lot of wacky theories historically have always started. There's something weird, there's something different, and people come up with something fanciful. So when Dame Jocelyn Bell, now Jocelyn Bell Burnell, had discovered this signal, she wrote on the kind of like output from the radio telescope, LGM, or Little Green Men. I think that's what it stood for, unless that story is apocryphal, but basically it was like, what is this? It must be aliens. And over the last, let's say 60 years, 50, 60 years, we have discovered hundreds and thousands of these pulsars. And we've been able to identify what causes them, what their physical origin is, but also what the mechanism is that's producing these very regular pulsations or bursts. And so, to kind of skip to the end, basically, when a very massive star, so you're talking, you know, several times the mass of our sun, up to about 20 or 30 times the mass of the sun, when it collapses in a powerful supernova, you have basically the star can no longer support itself. The nuclear burning that was pushing outwards against the forces of gravity, there's no more fuel to burn, so the star collapses inwards. You have this rapid explosion and generation of these super fast moving particles called neutrinos. Neutrino pressure pushes the explosion outwards. You have a supernova, but then you're left with the core, the remaining kind of dead core of the star. And that is a neutron star. It's basically all the material that couldn't completely collapse on itself in the supernova explosion, because there's so high density of neutrons, the subatomic particles, that they can't collapse any further onto themselves because they can't be in the same place and with the same energy. And it's a really cool area of study because what is happening on the inside of a neutron star is study for particle physics and quantum physics. What's happening on the outside is study for astrophysicists like me, because having these super dense and electrically charged objects means that you have these really, really dense objects with powerful magnetic fields, very, very powerful magnetic fields. And we have a process that leads to these neutron stars spinning really, really rapidly. Why they spin really rapidly? It's basically the result of conservation of angular momentum. So originally you have a star, and a star is rotating, and it rotates and rotates and rotates. But if you were to take all of that mass, or a large part of that mass, and condense it, it would rotate faster. If you the classical analogy that people give is one of an ice skater. So if there is an ice skater and he wants to slow down, he puts his arms out. So he's spread the mass over a wider area, so he spins more slowly. And if the ice skater then brings his arms in, he will start spinning faster. So following the supernova, there is a spinning up of the core in order to conserve that momentum, and the neutron star that remains is spun up and spins really, really, really ridiculously fast. It's very dense, very massive, spinning very fast with a strong magnetic field. Now, the exact physics of how the electrons of that material are hitting the magnetic fields is a whole other thing that a lot of people continue to work on, but basically there is a powerful beam of electromagnetic radiation that is projected from the poles, the magnetic poles of the neutron star, and that is what is sweeping across as the neutron star spins and creating this pulse of radiation that you see very strongly at radio wavelengths. So that's a long answer to a very short question. Basically, we understand the way that neutron stars form. We understand a lot of how they produce the energy and bursts that we see. We understand why these bursts are periodic and regularly repeating and very quick. And the sort of frequencies at which you see this emission covers a wide range and has a particular spectral shape, meaning in how bright it is at different wavelengths or different frequencies. When you see artificial emission, that tends to be, generally speaking, very narrow individual bands, and to individual bands, and to produce the sort of bright light that we're seeing from pulsars, across that entire band from a technological process or machine or something like that, doesn't really work with physics and doesn't make sense. So we have pretty good explanations and understandings of how pulsars work. And I'm going to stop talking now because I feel like I've been talking for too long.
I liked it, and everyone else liked it. I'm answering for them in the past, future,
or in the future.
I don't know. Well, this is how I just learned that I understood the concept of the neutron stars spinning super fast because all their density is condensed into a smaller area, and I understood that they shot out a beep 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 beam, but I did not know that, or maybe I've seen it before, but I just didn't know at the moment that it came out of the poles. That's kind of very interesting. So I learned.
Yes.
I
the
have
magnetic
learned.
poles.
Magnetic poles.
I'm learning.
Sorry.
Do we have time for one more?
Let's see if we can. I will see if I can squeeze in a small one.
This is going to have to be a 2-part episode, isn't it?
We're gonna have to do a 2-parter. Let's do a quick small one, and then we will. Excuse me. Then we'll make it a 2-parter. This one is about the NASA rover Opportunity in 2008 saw a mannish humanoid-like alien walking on the surface of Mars. This is not true. There are many things that have been taken, photos have been taken of on other worlds or out there in the universe, and that we as humans like these photos because we can kind of see familiar patterns in them, things that we're familiar with, such as eyes, noses, mouths, bodies, arms, legs, because these are shapes that we're used to. In 2008, Opportunity snapped a photo and sent it back to Earth of a creature walking on the horizon of some hill. and everybody went gaga. And it's often used in many conspiracy theorists, you know, documentation that proof of life and it's being covered up. And it's, of course, it's just like any other Bigfoot photo. It's very blurry. The reason it was so blurry is because the photograph as a whole, if you see the original photograph, which is very clear, is of a small rock amongst other rocks. And the reason it's so blurry is because if you zoom in into one little part of this photo, quite literally looking at the edge of something slightly bigger than a pebble, you will see this little crack or this little sharp edge to this pebble. And the way it happened to look at the time Opportunity took that photo, with the sun shining at the certain angle that it was shining, cast a certain shadow in a certain way, that little edge of a rock looked as if it was a person walking on a hillside. The hillside itself was the rock, and the person was just a crack on the top edge of the rock. It is not a creature or anything alive as we know of. Just a rock. Shadows,
I was
man.
getting so excited.
We can debunk so many conspiracy theories by saying it's a shadow.
I mean, that's basically the answer to the moon not rotating. It's like you'll see the shadow when it's just everything. Yeah, I think our next episode will definitely have to cover shadows in a bit more depth. But wow, I think one important thing just before we wrap up, like with respect to this, is as you said, like we have evolved for tens of thousands of years to recognize certain patterns and recognize certain shapes that are familiar to us, and that's fine. So it's understandable why our mind will play tricks on us sometimes. I think the danger is to kind of assume some fantastical thing is happening when the boring explanation is more reasonable. It's like that expression um, that if you hear hoofbeats, you should think horses, not zebras, right? Because statistically speaking, when you hear hoofbeats, for the most part, the most likely thing to be responsible for that when you stop and look and track down the source of the sound will be a horse. And only in some very rare situation, especially if you're like in the middle of some metropolitan city and not on the savannah or on safari, there's like some weird situation where maybe there was a zebra that escaped from the zoo and has ended up inside your office building. But is that likely? Right? So I think for all of these conspiracy theories, when there's some fantastical, extraordinary explanation for events, generally speaking, the more boring explanation is going to be much more likely and is probably the correct explanation. And I will leave it at that. That about wraps it up for this episode. I'm sorry, folks, to leave you hanging in this, our last episode of 2023. In fact, this is our last episode of the season, isn't it?
This is episode 10. So, yeah, we're going to call it quits for season 1 and a nice even 10 episodes. And we'll kick it off in 2024 with season part D.
Season part D. I'm very much looking forward to our second season. It's been a lot of fun so far. Me and the old Benny McBenny. Is that what I said before?
Yeah, Benny McBenny.
Benny McBenny face. Yeah. No, this has been good so far, and I'm looking forward to another year and many more seasons of Science Actually Presents The Nerd and the Scientist. Quickly before we go, where can the good people find you, Benjamin?
Thanks, Cops. You can find Science Actually primarily on Facebook, but you can also find Science Actually on TikTok and Threads and Mastodon and Hive and Instagram and LinkedIn. And if you close your eyes, go to sleep, say your prayers, and write Santa. You'll be visited.
You're going to say, if you close your eyes, you can hear us there.
you can hear us there, and you know, and on the 25th, Science Actually is gonna come down your chimney and leave you little science toys on your table. How about you, Cavs?
Fantastic.
Where you be at?
You can find my accounts on all of the social medias at Fun Fact Science or Fun Fact Science with Kovi. I will be there, you will be there, and please let us know in the comments what you think of the show. You can write us a review, like us, rate us, whether it's on Spotify, Apple Podcasts, anywhere. Let us know what you think, and we will see you in the next season of Science Actually Presents the Nerd